Imagine a star so dense, so strange, that it challenges everything we know about the universe. These stars are not just any ordinary celestial bodies, they are enigmas that push the boundaries of our understanding of space and time. This is the enigma of a gravastar, a theoretical object that might hold the key to unlocking some of the universe's deepest secrets. Gravastars are hypothesized to be even more mysterious than black holes, offering new insights into the fabric of the cosmos. Gravastars are thought to be incredibly compact, even more so than neutron stars. Neutron stars themselves are already known for their extreme density, but gravastars take this to an entirely new level. They are essentially shells of ultra-dense matter surrounding a central void. This unique structure sets them apart from any other known cosmic objects. This void, however, isn't empty space. Instead, it's thought to be filled with a strange form of dark energy, a mysterious force that scientists believe is accelerating the expansion of the universe. This dark energy could be the key to understanding why the universe is expanding at an ever-increasing rate. The concept of a gravastar is still very new. It challenges many of the established ideas in astrophysics and cosmology. It was first proposed in 2001 as an alternative to black holes. This proposal has sparked much debate and interest within the scientific community. While black holes are predicted by Einstein's theory of general relativity, they also create a paradox known as the information loss problem. This paradox has puzzled scientists for decades. Gravastars offer a potential solution to this problem, making them a fascinating area of study for physicists and astronomers alike. As research continues, gravastars may one day provide answers to some of the most profound questions about the universe. To understand gravastars, we need to understand gravity. Gravity is the force that pulls everything together. It's what keeps us on Earth, what makes the moon orbit the Earth, and what causes stars to form. Think of a bowling ball placed on a trampoline. The ball creates a dip in the trampoline surface, right? Now imagine rolling a marble across the trampoline. The marble will curve towards the bowling ball because of the dip. This is similar to how gravity works. Massive objects like stars and planets create a dip in space-time, and smaller objects are drawn towards them. The more massive an object, the stronger its gravitational pull. Gravastars, if they exist, would be incredibly massive, packing a huge amount of matter into a relatively small space. This intense gravity is key to their unusual properties. Both gravastars and black holes are incredibly dense objects with immense gravitational pull. These celestial phenomena captivate scientists and astronomers alike, as they represent some of the most extreme conditions in the universe. However, there are some key differences that set them apart and make them uniquely fascinating. A black hole is formed when a massive star collapses at the end of its life. This dramatic event marks the end of the star's life cycle, leading to a gravitational collapse. The collapse continues until all the matter is compressed into an infinitely small point called a singularity. This singularity is a region where the gravitational pull is so intense that it warps space and time. This singularity is surrounded by an event horizon, a boundary beyond which nothing, not even light, can escape. The event horizon marks the point of no return for anything that ventures too close. Gravastars, on the other hand, are proposed to have a shell of ultra-dense matter instead of a singularity. This theoretical shell is incredibly dense and compact. This shell prevents further collapse and creates a void at the center. The void is a stark contrast to the singularity found in black holes. This void is filled with dark energy, which pushes outwards, counteracting the inward pull of gravity. Dark energy plays a crucial role in maintaining the structure of a gravastar. One of the main differences between the two is that gravastars do not have an event horizon. This absence of an event horizon is a significant distinction. This means that unlike black holes, it might be possible for information to escape from a gravastar. The potential for information escape challenges our current understanding of cosmic phenomena. This difference has huge implications for our understanding of the universe and could solve the information loss paradox. By studying gravastars, we might unlock new insights into the fundamental workings of the cosmos and unravel some of its deepest mysteries. Dark energy is one of the most mysterious concepts in modern physics. We know it exists because we see its effects. The universe is not only expanding but also expanding at an accelerating rate, and dark energy is thought to be the driving force behind this acceleration. Think of baking a loaf of raisin bread. As the bread dough rises, the raisins within it move farther apart. This is similar to how galaxies are moving apart in our expanding universe. Now imagine the bread dough rising even faster and faster. That's the effect of dark energy. In Gravastars, dark energy is thought to play a crucial role. It's the outward pressure from dark energy within the Gravastar's central void that prevents it from collapsing further. This interplay between gravity and dark energy is what makes Gravastars so unique and potentially important for understanding the universe. One of the most mind-boggling implications of Gravastars is their potential connection to hidden dimensions. String theory, a popular theoretical framework in physics, suggests that our universe might have more than the three spatial dimensions, length, width, and height, that we experience. These extra dimensions are thought to be curled up and hidden from our view. Think of a garden hose viewed from a distance. It appears as a one-dimensional line. However, as you get closer, you see that it also has a second dimension, its circumference. Similarly, string theory suggests that our universe might have extra dimensions that are too small for us to detect directly. Some physicists believe that Gravastars could be gateways or wormholes connecting different parts of the universe, or even different universes altogether. These gateways would be made possible by the intense gravity and potential warping of space-time near a Gravastar, potentially offering shortcuts through these extra dimensions. Section 6. Searching for Gravastars, a cosmic treasure hunt. Finding Gravastars is a major challenge. They are incredibly small and faint, making them difficult to detect with current telescopes. However, astronomers are developing new techniques and instruments that might help us find these elusive objects. One promising approach is to look for gravitational waves. These are ripples in space-time caused by the acceleration of massive objects, like the collision of two black holes. Gravastars, if they exist, should also produce gravitational waves when they form or interact with other objects. Another strategy is to study the behavior of matter falling into a Gravastar. Unlike black holes, which swallow matter completely, Gravastars might leave behind a detectable echo as matter interacts with their outer shell. By carefully analyzing these echoes, astronomers might be able to distinguish Gravastars from black holes. Section 7. The Future of Astrophysics, Unveiling the Universe's Secrets. In this chapter, we delve into the cutting-edge research that is pushing the boundaries of our understanding of the cosmos. The study of Gravastars is still in its infancy. These mysterious objects, theorized to be an alternative to black holes, are captivating the minds of astrophysicists around the world. However, the potential implications are vast. Gravastars could hold the key to unlocking some of the most profound secrets of the universe. If we can prove their existence, Gravastars could revolutionize our understanding of gravity, dark energy, and the fundamental nature of space-time. This could lead to groundbreaking advancements in physics and cosmology. They could also provide crucial clues about the early universe, the nature of dark matter, and the possibility of extra dimensions. These insights could reshape our comprehension of the cosmos. Imagine a world where we can manipulate gravity, harness the power of dark energy, or even travel through wormholes to distant parts of the universe. The possibilities are as vast as the universe itself. While these ideas might seem like science fiction, the study of Gravastars and other exotic objects brings us closer to understanding if such possibilities might one day become reality. The line between science fiction and science fact is becoming increasingly blurred. The quest to understand Gravastars is a testament to human curiosity and our desire to explore the unknown. It embodies our relentless pursuit of knowledge and our drive to push the boundaries of what is possible. Each new discovery brings us closer to unraveling the mysteries of the cosmos and our place within it. The journey is ongoing, and the future holds endless possibilities for those who dare to look beyond the stars. Section 8. Gravastars and the Expansion of the Universe. The accelerating expansion of the universe is one of the biggest mysteries in modern cosmology. While dark energy is thought to be the driving force behind this expansion, its exact nature remains elusive. This is where Gravastars could play a crucial role in our understanding. If Gravastars are indeed filled with dark energy, studying them could provide valuable insights into the properties and behavior of this mysterious force. Imagine being able to study a concentrated form of dark energy right here in our cosmic backyard. By observing how Gravastars interact with their surroundings and how their internal dark energy affects their structure and evolution, we could gain a deeper understanding of how this force shapes the universe on a larger scale. This could lead to breakthroughs in our understanding of the universe's ultimate fate and whether it will continue to expand forever. Section 9. Conclusion. A universe of possibilities. The universe is full of wonders waiting to be discovered. Gravastars, with their unusual properties and potential connections to dark energy and hidden dimensions, represent just one of the many mysteries that continue to captivate our imagination. While the existence of gravastars remains theoretical, the search for them and other exotic objects pushes the boundaries of our knowledge and inspires us to ask profound questions about the nature of reality. As we continue to explore the cosmos, we can be sure that more surprises await us, each one challenging our assumptions and expanding our understanding of the universe and our place within it. The journey of discovery is far from over, and the future of astrophysics promises to be filled with exciting new revelations.